when we use the sine rule and when we use the cosine rule. Here I've got 8 different triangles. Take a look at these triangles and try to decide which one's a sine rule, which one's a cosine rule, and which ones are neither of them. Okay, let's look at the first one. So the first one, you can see that we have opposites here. So 8 is opposite x, 9 is opposite 70, and when we have opposites, we use the sine rule. So question 1 is the sine rule. We're not going to answer it. Question 2. So we've got a right angle triangle in question 2. So we wouldn't be looking at using the sine rule or the cosine rule. In fact, we're going to use, for 3 lengths of a right angle triangle, we'll be looking at Pythagoras. Question 3. So we're finding a length. We know 2 lengths and the angle in between them. So 2 lengths and the angle in between them, and that is the cosine rule. We don't have opposites, but we know 2 lengths with the angle in between them, so that's the cosine rule. Number 4 is the same. So we know 2 lengths, the angle in between them, so that's the cosine rule again. Question 5. We know all 3 lengths, and we're working out an angle, so that's the cosine rule to work out an angle. Question 6. Do we have opposites? So 8 is opposite 70, x is opposite 63, so this is the sine rule. Question 7. We've got a right angle triangle. We're finding an angle, so that is, alright, I'll call it SOHCAHTOA. And again with question 8, it's a right angle triangle. We know one of the angles and we're working out a length. We don't know the other 2 lengths, so it's SOHCAHTOA. So we use the sine rule when we've got opposites, the cosine rule to find a length when we know 2 lengths and the angle between them, and the cosine rule to find an angle when we know all 3 lengths. And for right angle triangles, we've got Pythagoras when it's just lengths, and SOHCAHTOA when there's an angle involved. Let's have a look at some sine rule and cosine rule questions. So which type of question is this? So is this a sine rule question or is it a cosine rule question? So we have opposites. We have x opposite 88 and 7.1 opposite 45. So it's a sine rule question. We want to find a length, so we put the lengths on top. So we're going to use a over sine A equals b over sine b. And we'll label it, we'll call x little a, opposite that's big A, and 7.1 can be little b, and opposite that big B. So substituting in, we're going to have x over sine 88 equals 7.1 over sine 45. We want x by itself, so we multiply both sides by sine 88. Then we type it into the calculator. So 7.1 over sine 45 times sine 88. And that gives us our answer of 10.03 to 2 decimal places. So we've got 10.03 it's centimeters to 2 decimal places. Okay, one for you to try. So pause the video and have a go. So it is again the sine rule. We've got opposites and we're finding a length, so we're going to put the lengths on top. So it's going to be a over sine A equals b over sine B. We'll call x little a, so opposite will be big A, and 5.1 little b, so opposite that will be big B. So substituting in, we've got x over sine 29 is equal to 5.1 over sine 92. To get x by itself, we multiply both sides by sine 29. So x is equal to 5.1 over sine 92 times sine 29. And we type it into the calculator. And our answer is 2.47 to 2 decimal places. It's meters to 2 dp. Okay, a different question. Take a second to figure out what rule we're using here. So we are working out the first one, angle ABC, A to B to C. That's this one. And we know all 3 lengths of the triangle. We're working out an angle, so that's the cosine rule for angles. So that one is cos A equals B squared plus C squared minus A squared over 2BC. So our big A is going to be our angle, our x. Opposite big A is little a. And the other two are B and C. And it doesn't matter which way round we have them. So let's substitute in. So we've got cos x equals B squared. So 5.7 squared plus C squared, which I've got as 4.2 squared, minus A squared, which is 3.1 squared. And that's all over 2BC. So 2 times 5.7 times 4.2. So we can type this into the calculator. So that's 5.7 squared plus 4.2 squared minus 3.1 squared over 2 times 5.7 times 4.2. So we've got 0.86, 0.846 and so on. So 0.846 and so on, but that's cos x, and we want x. So to get cos away from x, we shift cos the answer, and that's 32.19 degrees to 2 decimal places. Okay, one for you to try. So pause the video and have a go. We want ACB this time, ACB. So that's x. Again, it's the cosine rule for angles. So cos A equals B squared plus C squared minus A squared over 2BC. So big A is going to be our angle. Opposite big A is little a. And the other two are called B and C. So substituting in now, cos x equals B squared, so 6.5 squared, plus C squared, 8.4 squared, minus A squared, 10.1 squared, over 2BC, so 2 times 6.5 times 8.4. So let's type it into the calculator. So we've got 9 over 91, or 0.098 and so on. So 9 over 91. So cos x is 9 over 91. We want x, so to get cos away from x, let's shift cos the answer, and we get our angle of 84.32 to 2 decimal places. It's an angle, so it's in degrees, to 2 decimal places. Okay, next question. So take a second again, figure out which rule we're using here. So we're finding a length. We know 2 lengths already, and the angle in between them. So this is the cosine rule. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. So our angle is our big A, opposite that is little a, and the other two are b and c. So let's substitute into our rule. So we've got x squared equals 7 squared plus 12 squared minus 2 times 7 times 12 cos 43. And let's type the whole of the right side into the calculator. So we have 7 squared plus 12 squared minus 2 times 7 times 12 cos 43. So we've got x squared is equal to 70.13 and so on. So x squared is 70.13 and so on. So to get x, we square root. So square root the answer, and that's 8.37 to 2 decimal places. And it's in centimeters. Okay, one for you to try. So pause the video and give that a go. So we are finding BC. And again, it's the cosine rule. We know 2 lengths and the angle between them, and we're finding the other length. So we're going to have big A as the angle, opposite big A is little a, and the other two, either way round, are called B and C. So substituting in, so we've got x squared equals 2.5 squared plus 4.4 squared minus 2 times 2.5 times 4.4 cos 54. So type that into the calculator. So that's 2.5 squared plus 4.4 squared minus 2 times 2.5 times 4.4 cos 54, and that's got us 12.67 and so on. So x squared is 12.67 and so on. We want x, so we're going to square root the answer, and that's 3.56 to 2 decimal places. So 3.56 is in centimeters to 2 dp. And the next one. So again, take a second, figure out which rule we're using for this one. So we're asked to find the angle of ABC. So ABC, that's this angle here. And we have opposites, which means we are working with the sine rule. It's the sine rule this time, and it's an angle we're working out. So we're going to have sine A over A is sine B over B. To work out an angle, we're going to put the angles on top. So let's substitute in. So we've got sine X over its opposite, which is 2.4, is equal to sine 38 over that's opposite, which is 3. To get sine X by itself, we're going to multiply both sides by 2.4. So we get sine X equals sine 38 over 3 times 2.4. And we type that into the calculator. Sine 38 over 3 times 2.4. So we've got 0.492 and so on. So sine X equals 0.492 and so on. We want X. To get sine away from X, we're going to shift sine. So shift sine the answer, which gets us 29.51. 29.51 degrees to 2 decimal places. And one for you to try. So pause the video and give it a go. So we've got opposites. We're working out an angle. So we're going to put the angles on top. We've got sine X over its opposite, which is 2.2, equals sine 97 over its opposite, which is 4.4. To get sine X by itself, multiply both sides by 2.2. So sine X is going to be sine 97 over 4.4 times 2.2. So we'll type that into the calculator. Sine 97 over 4.4 times 2.2, 0.496 and so on. 0.496 and so on. To get X by itself, we're going to shift sine. So we've got 29.75. 29.75 degrees to 2 decimal places. And let's finish up with 2 questions. So find out the answers to these, either using the sine rule or the cosine rule. Right, the first one, find the length of BC. So that is B to C is this length. We know the other 2 lengths and the angle between them, so we can use the cosine rule. So the cosine rule says A squared equals B squared plus C squared minus 2BC cos A. So big A will be our angle, little a is opposite big A, and the other 2 are B and C. So let's substitute. So we've got x squared equals 6 squared plus 9 squared minus 2 times 6 times 9 cos 100. So let's write the whole right side into the calculator. 6 squared plus 9 squared minus 2 times 6 times 9 cos 100. So we get our x squared as 135.75 and so on. 135.75 and so on, but that's x squared. We want x, so we square root the answer, 11.65. So 11.65, it's in centimeters to 2 decimal places. For question 2, we have opposites. So x is opposite 9, 94 degrees is opposite 11.5. So we can use the sine rule, and we're finding an angle, so we're going to put the angles on top. So we're going to have sine A over A equals sine B over B. X will be big A, opposite big A, little a, and the other angle's big B, and opposite that is little b. So let's substitute these in. We've got sine x over 9 equals sine 94 over 11.5. So to get sine x by itself, multiply both sides by 9. So sine x is equal to sine 94 over 11.5 times 9. So let's type that in the calculator and find out what sine x is. Sine 94 over 11.5 times 9. So sine x is 0.780 and so on. And to get x by itself, we're going to shift sign. So shift sign the answer, and we've got 51.32. 51.32 degrees to 2 decimal places.